Hello, my name is Brian. I'm a mechanical engineering major. It is known that many math and science-related courses are needed for my field of study, but what is calculus? Who uses it, and what is it used for? Let's find out. What is calculus? Calculus is the study of change. It was invented by English physicist and mathematician Sir Isaac Newton and German mathematician Gottfried Wilhelm Leibniz. However, there's controversy on who created it first. Nevertheless, calculus is built on previous mathematical concepts. K. Lee Lerner, who was a writer and scholar of Harvard University, states the following. Important mathematical developments that laid the foundation for calculus of Newton and Leibniz can be traced back to mathematical techniques first advanced in ancient Greece and Rome. There are three major components to calculus. They are differentiation, integration, and limits. I'll give a brief explanation as to what these are. First, I will explain what limits are. This is because limits lay the foundation for calculus and are used for differentiation and integration. For example, let's take a function of x. As x approaches some value, it goes towards a y value. This displays the behavior of a function at a given point. As for derivative, it is an instantaneous rate of change of a function. In other words, it is the slope of a tangent line at a given point. This is a major concept to grasp when it comes to calculus. Last but not least, integration is the inverse of a derivative. It is also known as the antiderivative. It is used to find the area under a curve. Integration has the ability to take a piece of something and shrink it infinitesimally in order to find the area. Now that we know what calculus is, who uses it? Many professionals use calculus. These include astronomers, scientists, chemists, physicists, animators, engineers, and the list goes on. Despite the many professions that utilize calculus, I'll be focusing on mechanical engineers. Mechanical engineering is very broad and covers a variety of topics. It includes researching, designing, constructing, and testing mechanical devices. These devices being tools, vehicles, engines, and machines. With mechanical engineering being so broad, there are many subdisciplines. They include aerospace, automotive, biomedical, construction, and robotics engineering. The one that I'm most interested in is aerospace engineering. Aerospace engineers design, manufacture, and test aircraft, missiles, satellites, and other aerial crafts and equipment. Now that we know who uses calculus, the real question is, what is it used for? I thought that there would be no better way to find out what an aerospace engineer uses calculus for than to ask one.
Jackson. I work at the Armstrong Flight Research Center out in the Mojave Desert in California, where I am a deputy project manager for Skyrange.
After receiving his email from a subject matter expert presentation for NCOS Mission 1 Discover, I asked him if he runs into calculus often and what he uses it for. He was more than glad to answer my question. When it comes to the basics, whenever there is a velocity, rate, or equations for three-dimensional motions, calculus is needed. He then went on to give professions that come into contact with calculus regularly. These professions include aerodynamicists, stress engineers, and vehicle design engineers. In Mr. Jackson's current position as a project manager, he does not use a lot of calculus. However, he still uses it to predict costs over time. The calculus used involves a rate. In his words, if I know we're spending X dollars over a period of months, then I know how much money in total will be spent. As a project manager, I am sure that this is essential. It goes on to say that it is helpful to have a general understanding and awareness of calculus. I was also curious as to how the calculations were done. Most of the math is done with tools such as Python and MATLAB. Hand calculations are usually for rough estimates. I decided to do further research and found that there are many applications of calculus in mechanical engineering. Calculus is used in the design process for things such as cars, robots, pumps, and household appliances. For aerospace engineering, there are things such as the ideal rocket equation. I will go into depth on this later on. Analyzing rockets that contain multiple stages requires a great deal of calculus as well. Calculus can be applied in order to create models such as modeling gravity over time and space, and most physics models that deal with complex systems. A specific example of aerospace engineers using calculus that I've mentioned previously involves a rocket. Thrust over an amount of time can be calculated using the ideal rocket equation. Since there are many components that change such as mass, velocity, and pressure, calculus must be used. For example, the mass of a rocket changes because the mass of the propellant decreases as it is released through the exhaust. Since this is a change of mass over time, this deals with derivatives. The final step in achieving the ideal rocket equation will be integrating to find a change in velocity. The final ideal rocket equation can be seen here. This is in relation to free space. In other words, air resistance, drag, and gravity do not come into play. Calculus is also applied in automotive engineering, which is another subdiscipline of mechanical engineering. This deals with the design and manufacturing of vehicles. I found an example in which calculus is used in the design process of an engine. To be specific, it involves volumes of revolution. This is a caterpillar piston. It helps determine the compression ratio. A compression ratio measures how much the volume of the cylinder in an internal combustion engine is being compressed. The higher the compression ratio, the larger the combustion is. Engines and their components vary greatly depending on the desired outcome. In this case, let's say an automotive engineer wants to change the design of a caterpillar piston in order to change the compression ratio. If the caterpillar piston were to be sliced in half, it will look something like this. Looks familiar, right? This can be represented as a function, y equals f of x. Now, limits can be added. The limits will be from 0, the center of the piston, to the edge of the function. In this case, I will say that the limits are from 0 to 5. At this point, the shell method can be used. This is a method used for finding the volumes of solids of revolutions. A cylinder will be utilized. In order to get the outside shell of the cylinder, the circumference must be multiplied by the height. The radius will be represented by the x values of the function. 2 pi can be pulled out of the definite integral. Let's not forget the main idea of undergoing this process. Now that this is set up, changes can be made using calculus in order to aid with the design process. As stated before, an automotive engineer wants to increase the compression ratio. In this case, the function will be altered in a way in which the volume of the revolve cut is decreased. Altering the function may not be done by hand. However, it is important to know the underlying concepts. Using calculus is a great way to test and simulate designs without wasting resources. The list of calculus applications goes on. This is mainly because mechanical engineering is so broad, as was stated before. There are aspects such as calculating the surface areas of irregularly shaped objects with integrals. This will be done to find the frictional forces acting upon the object. Calculus being used in design is a common concept. A detailed example of this was displayed with the caterpillar piston, but it is also used to design pumps and deals with flow rates. Since mechanical engineers dabble in many concepts, they also calculate how much power is being provided in a battery system. Differential equations are also utilized. For example, Newton's law of cooling is essential in designing HVAC systems. In this case, integration will be required. As you can see, there are numerous ways in which calculus is used by the engineer. To recap, I have discussed the various applications of calculus in disciplines that require mechanical engineering, such as the ideal rocket equation, design, and calculating surface area. The individuals who use calculus were also discussed. An aerospace engineer for NASA was able to give key insight and introduce where and how calculus is used. Through further research, it was interesting to see that people who use calculus were not limited to scientists and engineers, but included individuals like animators. This goes to show just how important calculus really is. To give a solid foundation to the discussed topics, I was able to go into what calculus is and its history, which includes Sir Isaac Newton and Leibniz. Now I know what calculus is, who uses it, and what it is used for.